Okay, good day, students. Today I am going to explain important questions in first year, second sem physics, that is thermal physics. Our paper title is thermal physics. Okay, right. So, here we have the first unit is kinetic theory of gases. Right, in this kinetic theory of gases, the first important question is our deduction of Maxwell's law of distribution of molecular speeds. Okay, very important question, right? Previously asked question. Okay, very important for long answer, 12 marks, right? So, right here in the second one, and the here see, in kinetic theory of the in unit 1 the kinetic theory of gases, and we have thermodynamics, two parts of the unit 1. In this first part, first question is itself important, that is Maxwell's law of distribution of molecular speeds. Okay, so this is very important and previously asked question. Uh, next we have transport phenomena. In the first unit, first chapter, that is kinetic theory of gases, next important topics are transport phenomena. In that we have three phenomena. Those are viscosity of gases, thermal conductivity, diffusion of gases. We have three questions, right? So Maxwell distribution of molecular speeds, and one of these, he may ask one of these questions, that is in transport phenomena. We have viscosity of gases, thermal conductivity, and diffusion of gases. So here he may ask any one question from the transport phenomena. So in the first chapter we have two important questions. One is Maxwell's law of distribution of molecular speeds, second one transport phenomena. Here see, if you come to transport phenomena, we have three applications, that is viscosity of gases, thermal conductivity, diffusion of gases. See, if you get one answer, if you prepare one answer, it is very easy to prepare the other two answers, because the pattern is same, nothing but the method is same, the same solving. Okay, solving is there, so it is not more difficult to prepare the other two questions. If you prepare one of these three questions, it is easy to prepare the other two questions, because the method is same, the diagram is same, just. So in unit 1 we have two chapters, kinetic theory of gases, thermodynamics. In thermodynamics we have two important questions, those are Maxwell distribution of molecular speeds and transport phenomena. Next, in thermodynamics, if we see, for thermodynamics we have basic thermodynamics. Here Carnot's engine is only qualitative. Okay, neta value we know 1 minus T2 by. Okay, so here we will see only qualitative. So here we see only qualitative value of Carnot's engine. We will find the efficiency of Carnot's engine. So he may ask for problems for short answers, right? The important long answers are what? He may ask TS diagram. Important one is TS diagram, temperature entropy diagram, already previously asked question. And for long answers, he may ask uh, two or three questions in one question. Nothing but what he may ask: change in entropy in reversible and irreversible process. And he may combine this question with change of entropy for perfect gas, or when ice changes into steam. Like that, he may ask multiple questions in one question for long answer. Mostly asked question is TS diagram. Okay, so see, at least if you prepare complete one chapter, okay, about from these two chapters, you will attempt one long question. Either you completely prepare the second chapter, or completely prepare the first chapter. If you completely prepare the first chapter, it is very easy for preparing first chapter. Maximum he will ask this Maxwell distribution of molecular speeds. Okay, or else he may ask one of the application of transport phenomena. Okay, for 12 marks. So it is better to prepare for long. I am suggesting you that if you have less time, okay, prepare only one chapter from the first unit, that is what kinetic theory of gases, right? Next, see, okay, next see here in the, and for short answers you may ask transport phenomena for short answers also, okay? And in thermodynamics you may ask what is the definition of entropy, entropy disorder, entropy of universe, okay? So like that, you may ask reversible and irreversible process, what are reversible and irreversible process for short answers, okay? And you may ask problems for on Carnot's engine. Neta is efficiency of Carnot's engine. Okay, neta is equal to 1 minus T2 by T1. Next, second unit, that is thermodynamic potentials and Maxwell's equations. In this second unit also, the first topic is important. The first topic is important, that is thermodynamic potentials. Okay, that is thermodynamic potentials. So so here in second unit, dynamic potentials, derive Maxwell's thermodynamic relations. Okay, in second unit the important question is what? Thermodynamic, and derive the Maxwell's equations from thermodynamic potentials. It is important question, right? So it is very very important, you have to prepare for it. Thermodynamic potential, Maxwell's equations from thermodynamic potentials. So this is the long answer. Okay, we can expect from the here also in second unit we have two chapters again. Okay, thermodynamic potentials and Maxwell's equations, low temperature physics. Okay, in first part here we have maybe we have two long answers here. One is thermodynamic potentials and derive Maxwell's equation from thermodynamic potentials. Okay, first long answer. You may ask class S Clapeyron equation combined with derivation for specific heats, like that. Okay, right? He may ask by combining two three questions in one question. Class S Clapeyron equation and difference of specific heats, okay? And Joule Kelvin effect for Joule Kelvin effect, okay, for perfect gas and van der Waals gas, like that. Okay, he may ask by combining two to three questions for a long answer. So in, if you prepare completely this second unit chapter, okay, you may get one long answer. Okay, so without any, actually whatever the thermal physics, whatever the syllabus given to you, it is actually 1 year syllabus. Okay, we are completing this 1 year syllabus in 3 to 4 months, because we have only, it is a semester system. Syllabus is for 1 year syllabus, 1 year course. Okay, but so to avoid the difficulty to write the exam, it is we have to follow these tricks. Okay, so for simplicity of preparation, so just prepare one chapter. Okay, just prepare from one chapter from each unit, it is better. Okay, to save your energy, right? So it is very difficult to prepare all the topics, because they are, we have huge syllabus, okay, in thermal physics. So it is better to prepare some of the topics, like, okay, one of the unit, one chapter, like in unit 2 prepare one chapter. Second chapter, if you see second chapter, we have low temperature physics. In low temperature physics, the important questions are, see, the first question is important, that is Joule Kelvin effect and lift in porous plug experiment. Okay, and second one, we have adiabatic demagnetization. Okay, adiabatic demagnetization, sometimes you may ask Kapitz. So mostly asked question is adiabatic demagnetization. Okay, sometimes you may ask porous plug experiment, Joule Kelvin effect. And again another mostly asked question is vapor compression machine or vape. Okay, So production of low temperatures by principle of refrigeration and vapor compression machine. So in second chapter mostly asked questions are adiabatic demagnetization and vapor compression machine. Sometimes, okay, Joule Kelvin effect and porous plug experiment and Kapitja's method. Okay, so these are the important long answer questions in second unit, second chapter. Okay, right. So these are the important questions. Now for short answers, you may ask derivation of ratio of specific heats. Okay, difference of specific heats, Joule Kelvin effect, coefficient of Joule Kelvin effect per perfect gas. Like that, you may ask short answers questions. You may ask these short answers questions combinedly in a long answer also. So it is better to prepare all the chapter, complete second unit first chapter. You will able to write the one long answer question and two short answer questions. Okay, so like this is the one of the trick. Okay, because the syllabus is heavy. Next, in unit 3, in unit 3, okay, see, it is in, again this unit 3 is divided into, see, quantum theory of radiation. Again this is divided into some laws. Okay, this unit is divided into two parts. Okay, right. See, up to Wien's law, Rayleigh's law, and Planck's law measurement, whatever the black body, okay, black body, Wien's law, Rayleigh's law, up to here one part, and the second part is pyrometers, okay, disappearing filament optical pyrometer, experimental determination, pyrheliometer, okay, pyrheliometer. If you see, if you see here, the third unit, the third unit is divided into, the third unit is divided into two parts. Up to here, up to here, so black body, Ferri's black body, okay, distribution of energy spectrum, black body, Wien's black body, okay, Wien's law, Rayleigh's law, quantum theory of radiation, Planck's law. Up to here we have one part. And pyrometers, disappearing pyrometer, angstrom pyrheliometer, solar constant, effective temperature is another part. So in the first part, the important questions are Wien's law, Rayleigh's law, deduction of Wien's law, quantum theory of Planck's law, okay, deduction of Wien's law, Rayleigh's law, okay, and Stephen's law from Planck's law. So here we have three questions, three or four questions, important long answers in first part, that is deduction of Wien's law, Rayleigh's law, quantum Planck's law, and obtaining Wien's law, Rayleigh's law, Stephen's law from Planck's law. So completely we have four questions, four long answers. Important questions are disappearing filament optical pyrometer, one is one long answer, angstrom pyrheliometer, the second long answer. So, and for short answer you may ask determination of solar constant, okay, uh, determination of, that is angstrom pyrheliometer, determination of solar constant. And you may ask for short answer effective temperature of sun. So it is better to prepare the second part, that is pyrometers. Okay, because in the first part, we have four long answers. You may ask Wien's law, Rayleigh's law, and Planck's law, and deduction of Wien's law, Rayleigh's law from Planck's law. Okay, so four long answers. And here, if you prepare second part, compulsory you may ask one of the question from first part and one question from long answer from second part. So for long answer you will go for this disappearing filament optical pyrometer and angstrom pyrheliometer. So these are from these two questions you may ask one long answer. Okay, okay, So it is better to prepare the second part, pyrometers. Okay, we have only two long answers. If you go for the first part, we have four long answers. So even if you are interested to prepare the first part, prepare only this Planck's law, deduction of Planck's law, and different laws, Wien's law, Rayleigh's law from Planck's law, and prepare these two questions, what disappearing optical pyrometer and angstrom pyrheliometer. Okay, so next we will go for fourth unit. See, fourth unit is very, very important and very, very simple. Okay, fourth unit is very, very simple unit, right? So in this unit we have only three long answers. In from that you will get two long answers. You have to write one long answer, because this is not a COVID pattern. Okay, I'm okay. I forgot to say this. See here, now the question paper pattern is non-COVID pattern. So you, for long answer for part B, you have A or B two questions. You have to attend only one question. In the previous exam COVID pattern, you have that you can attend both the questions from one unit. Okay, but now at the present situation there is no COVID pattern, only it is non-COVID pattern, and you have to attend only one question from one unit, either A or B. So here you will get, in the fourth unit you will get three long answers. Those are, what we can say, Maxwell distribution, okay, Bose-Einstein distribution, Fermi-Dirac distribution, with one example. Three questions, we have three questions. In that you will get two long answers. He may ask Maxwell-Boltzmann law and Bose distribution law, or Fermi-Dirac distribution law, or he may ask these questions, that is Maxwell distribution law or Fermi Dirac distribution law or Bose-Einstein distribution law, and versus he may ask compare these three laws, distribution laws. Nothing but what you have to explain within some points, what is Maxwell Boltzmann distribution law, what is Bose-Einstein distribution law, and Fermi Dirac. Okay, now the difference between these three, okay, in your unit. So you have that answer, you go through that answer. Okay, so like this, in the fourth is very, very simple and very, very easy. Don't neglect this unit, because it is very simple and very important. You can score more marks from the fourth unit. Okay, because we have only three long answers. In that you will get two long answers. At least you prepare two long answers, you will get one long answer. Okay, at least you prepare two long, either Maxwell distribution law or Bose-Einstein distribution law. If you prepare these two, at least you will get one. Or you prepare three laws difference. Okay, three laws difference. So like that, the fourth unit we have three long answers. In that you will get two long answers, you have to write only one. And for short answers, you may ask postulates of statistical mechanics, phase space, concept of ensembles and some known ensembles, and what is the difference between quantum statistics. This is the previously asked question, classical and quantum statistics difference. Okay, so and he may ask concept of probability, definition of probability. He asked previously asked question. Okay, so like that, these are the important questions in what, semester 1. Okay, semester 1. See, lastly I will say, don't neglect these questions. In from first unit, compulsory uh, question is what, maximum gunshot question is Maxwell distribution of molecular speeds. In the, and in thermodynamics, TS diagram. Second unit, thermodynamic potentials, derivation of Maxwell's thermodynamic relations from thermodynamic potentials. Okay, compulsory question. And in this low temperature physics, you may ask maximum adiabatic demagnetization. These are the gunshot questions I am explaining fastly. So quantum theory of radiation, in this quantum theory of radiation, gunshot question is Planck's law, derivation of Planck's law. Okay, and angstrom pyrheliometer and disappearing filament optical pyrometer. Okay, these are the gunshot questions from third unit. And fourth unit I explained just now, three long answers you have to learn Maxwell distribution law and Bose-Einstein distribution law and Fermi-Dirac distribution law. At least you prepare two long answers, you will get one long answer in the exam, right? So these are the gunshot questions and important questions. Okay, so for more videos subscribe my channel. Okay, wish you all the best. Thank you.